Okay. So one way to solve the bias variance trade-off problem is you minimize something called MSE, which is variance of whatever parameter you have plus bias square. This is the quantity you minimize. So bias can be positive or negative. That's why you are squaring it. And also by squaring, you are getting it to be the equal units of measurement in terms of the variance.
Yes.
And if you add these two things up, that gives you the MSE.
Yes.
Okay. So you can minimize this quantity with respect to beta with respect to lambda.
Yes. Sorry, maybe a quick question here. For that one, is that the one where we're doing the log likelihood and then we're doing setting that equal to 0?
No, this is not related to log likelihood. At least not in general.
Hold on one second.
We'll
Minimizing.
still do a setting derivative to 0 kind of thing, but not related to the log likelihood.
Okay, got it. That was from above. Minimizing MSE was from above. I'm
That's
mixing up MSE and MLE. Okay,
that was minimizing sum of squares of
MLE.
error, not MSE. That was and MLE likelihood kind of thing.
MLE.
Okay.
Yeah, sorry.
Okay. Yeah, there are too many acronyms, so please be careful. Okay. The second is cross validation.
Oh, he mentioned the k-fold cross-validation, he said.
Yes. So what you do is you divide your data set into maybe k equals 10 parts. You use any 9 of them at a time and see how much the prediction error is on the 10th. And then you rotate this, which guy will play the role of the 10th. And then you add up all the sum of squares of errors, and that gives you a methodology to do it. This is like a general thing that this is something that people have devised so that this will work for no matter what your machine learning method is.
Oh, interesting.
So
Okay.
like you don't have to think of a new method every time you have a new model or anything.
Got it. Okay.
You can just do a
That's
k-fold
super
cross
cool.
validation, rotating data and finding it.
Got it.
And that will tell you which lambda to choose.
Got it.
Okay. So what will typically happen is, let me see if I can introduce a quick plot for cross validation. Is there no insert picture connection? Okay. So in the x-axis, my lines are not straight, but please
No
bear
worries.
with
No
that.
worries. Yes.
Yes.
I think you have, yeah.
Yeah. So my x-axis is lambda and y-axis is the total error.
Okay.
And then typically what you see is so sorry, I'm really bad with this. I can't. I just wanted to show a very simple picture of how the cross validation look like. Yeah. So typically you see some picture like this. As you increase the lambda, so if your lambda is very small, then your bias variance total cross validation error or trade-off is high. If you keep increasing the lambda, you get a minima somewhere, and then it keep increasing again.
So there's some sweet spot there.
Yeah, there is some sweet spot. So this is what you expect for this kind of thing.
Very cool. And then can I maybe guess, is there some sort of where you're finding the minimum value here in order to
Yes.
find?
Yes. This you don't like apply any, people don't usually apply very sophisticated method. They just like, you can choose 10 different values of lambda and then see which one gives me.
So wait, just to clarify the axes here, the x-axis is lambda, the y-axis is MSE then, right?
Let me write down.
X-axis is your lambda, and
Yeah,
then y-axis is your
that's it.
MSE. Got it. And then maybe an advanced question too, as we go into more machine learning models, is lambda the only hyperparameter then, or there's, assuming there's
Uh,
other.
for this model, lambda is the only one. In
Okay,
other models, there might be more.
there might be more. So we'd have to pick other hyperparameters then as well. But is all
So
of them then based on the MSE where there's variance and bias trade-off then for those?
need not be. There are other methods, but cross-validation generally works for most methods.
Cross-validation. Okay.
Like it's a general tool, and you don't need any formula or anything. For bias variance instead of to work, you need to derive this formula. Like you need to know the formula for bias and formula for variance,
Got it.
which may not be easy for a complicated model.
Okay.
So that's like the idea. But cross-validation, you can like it's a data kind of thing.
Got it.
You just run the model and see what numbers you get.
Got it.
Bias variance trade-off is more like a theoretical way of deriving it.
That makes sense.